Here we are. Welcome, everyone. I hope you're doing well. I'm doing this by myself, so warning, there are going to be problems, but the fun ones, I really hope. So let's do a sound check. Can everyone hear me? If you can post on the chats, I'll be doing all the stuff. Good. Let's see. I'm waiting for the replies. Hi. Hello. Can you hear me? That's my question. Yes, thank you very much. Doog Effects replied. So I'm going to go through the housekeeping pretty quickly when I find the appropriate window. I can't find my appropriate windows. Never. That's a curse. And I've got too many windows open. This is the let's see. There we go. Found it. Bring it over. Maximize it. And now share it. So let me go here and share my screen. Fantastic. So there's this great little page here, maxon.net/English or whatever language, ask your question. And here we have pretty much all the information you need. You can ask the questions because this was a surprise stream. It's not in the upcoming live streams. And you can ask your questions here with this short questionnaire, and everything else that relates to our streams, events and stuff like that. You just go and click these links and do whatever you want to do. Now, there is this interesting, I need to find it here, QR code thingy, madoodle doody thing. And when you snap this, it will actually allow you to ask questions. So a very quick way for you to go and ask your question. So take a screen grab of this, or if you're watching it. By the way, if you are going to watch this recorded, that will be on the Maxon Training Team YouTube channel, although it's live streamed on both the Maxon Training Team channel and the Maxon YouTube channel. And let me hide this now. And let's quickly go through this. First of all, Maxon events, all the fun stuff, and all the amazing new news and the fantastic work from Something's Awry. Watch that short video. It's beautiful and utilizes a lot of the new technologies. The Maxon Training Team YouTube channel, where all the fantastic stuff happens. Don't take your kids to the movies. Just put a screen up and watch Maxon Training Team YouTube channel, or the Maxon YouTube channel, or the Maxon ZBrush YouTube channel. And I think the code for this week, if you want to get a little t-shirt thingy as a token of appreciation, is a ZBrush print prep. Right, so take a snapshot of that and claim your t-shirt at this link over here, which is, I'm doing everything myself. So here is the link to the t-shirts. Fantastic. And of course, visit Cineversity. Let me take this off here. And that first page I showed you has links to all these things, so don't worry. Now, today, you may have already realized I'm going to talk about particles, right? Ain't that fun? And I've created 40 tutorials, and more are coming. This is going to be one of the longest running series and tutorial number ever been produced. We have the particles overview, if you want a general idea very quickly in 11 videos what's going on. And this one is more detailed about the tools and so forth. What I'm preparing now, and let me of course, go to the old Cineversity and look at all the amazing stuff we've been doing over the years. And let me put my beautiful face up here. There we go. And what I was going to say is that, first of all, we would love some input. So download the latest version, play around with the watch the tutorials, play around with the particles, take notes, and ask questions. I'm going to reply to anything I can today, but it will be great to hear your feedback. It's very important to us. And the way you would do it is first watch the overview to get a general idea where the interface is and what's going on, and then start watching the tools and settings. That will give you a better insight on all the numbers, the little dials, the stuff. And what I'm preparing now is how-to videos. So how do we do particles on a two-dimensional plane? And I'm offering 3 methods. How do we make particles do something very specific? How do you combine particles with MoGraph cloners and all that? I'm going to give you some quick examples today, and I'm going to deal with some of the questions. So I'm going to be looking at the chat at the same time. And without further ado, that's what usually people say. I'm going to remove my face so you can get a better view of what we're doing. So this is a fun setup. The other day, someone said, "Oh, I saw this little rock paper scissors game," and what we're seeing here is actually rock paper scissors played by the particle system, and this is done through 3 predator prey modifiers. A collide modifier which keeps them in bound, and yeah, whenever they meet, a scissors wins over the paper and becomes a scissor. A rock wins over when it encounters the scissors, and paper wins over when it encounters a rock. And yeah, you can play with your friends. So if nothing else, get max on 1 and play rock paper scissors with your friends, or whatever you want, or make some money. Yeah, that's an option. Start a business, do great motion graphics. Good. The one thing. Oh, Vitus wants to make a coffee. All right. So let's wait for the coffee to brew, and let's see what happens here. What do you think? Who's going to win? Right? It's going. Let me, for the next 1 minute, I want people to post if rock, paper, or scissors is going to win. All right. Let's see. I'm going to give you 10 seconds. 9, 8, 7, 6. Let's see. No one? No one is hedging a bet? Rock, paper. All right. Rock. Depending on the randomization, this may never end. There's always a mathematical chance that will never end. Stalemate. Yeah, stalemate. This is boring. Okay, Sebastian, this is boring. Okay, let's do something a bit more interesting. Sebastian, ask your particle question. I will only be dealing with particles today. We're not going to address other things. I'm going to show you some ready-made examples that I'm posting on Twitter as well. So this is an automatic way where we just generate some spheres and they roll in random directions on a plane. At the same time, they have some sort. There's no collision here. It's just avoidance looking the flock modifier. We are going to do some setups from scratch. And it's a combination. One thing for anyone that uses MoGraph is that down here, if you're using particles as a source of a clone set to object mode, you get this new thing. Age is what we usually had. It will just map 1 second of lifetime to 1 second of animation for any animated clones that have keyframed animation. Doesn't work with procedural animation, works with keyframed animation. You will see that we have this rolling here. But now we have this new thing that deals with distance. So you can tell it to play a second of frames of animation when it covers this amount of distance. And the great thing about this is that if something is going slower, it will roll slower. And something going faster, it will roll faster. And another application of this is something that simulates a crowd simulation. It's not a crowd simulation, but it simulates that. This is an alembic file, and we're generating particles with that alembic file. And because I'm using the flock to create some sort of avoidance plus turbulence and stuff like that. And this is live, playing live. I have a few-year-old PC with an RTX 5000, and it's chugging along. And the slower these guys go, the slower their animation is going to be. So you can make some interesting motion graphic-y stuff. It's no replacement for real crowd simulations, but nonetheless, it's fun. The thing I am going to show from scratch, and just going to whet your appetites a bit, is the performance, right? And this is a combination of a Pyro simulation, which I've turned off the visibility, that's pushing these particles. And the number of particles we are pushing currently is, let me see here, how many particles are we pushing? Not empty group, this group. This is 1 million particles, and what you're seeing is the playback time, plus I'm streaming from the same computer. So, why not? It's all about the zeros. Let's go and do 10 million. It's going to be a bit slower, but we are actually shooting 10 million particles. And what you're seeing is the raw performance of an RTX 5000 when it's live simulating 10 million particles. Okay. And it's not too shabby if you have one of those fancy 40 series cards. This is going to be significantly faster. And RAM is always a good thing. VRAM is always a good thing. So this is the kind of performance you would expect as long as you're using things which are confined to the GPU. And this is one of the big, let's say, things you need to consider when it comes to performance. And I've made a video about that. For performance, there are two main things. If you're using fields or anything that belongs to classic Cinema 4D to affect your particles, you are going to have slowdowns because, and this is still chugging, right, with 10 million particles. What happens? Let me show my face here. So, this one or this one? I don't know. I can't choose which one. I'm going to put this one up. So, the way GPUs work, and this applies generally to the technology, is that the CPU sets up the data, it sends it to the GPU to do the calculation. If the CPU requires to retrieve that information from the GPU to do something, for example, fields, because fields is predominantly 100% built in Cinema 4D's classic, let's say, CPU subsystem. So if you're doing some sort of field condition or anything that affects the simulation using fields, every time a frame is executed, and the execution of that frame for those 10 million, 20 million particles is going to be very fast. But then all the data from those particles need to come down back to the CPU. And this is the bottleneck that CPU, GPU technologies have to face, that they work in two different contexts, right? We have the VRAM, which is on the GPU, and the RAM on the CPU. And the data needs to travel through your computer, bus chips, and all that kind of stuff. So there are going to be occasions when you use specific tools that are going to slow down your simulation. Keep that in mind. But there are tricks to keep as much as possible of it in your GPU exclusively, which is an example of here the simulation interaction with Pyro, so the Pyro and the particles. The other thing is when you're using, that's the second thing I want to mention. And let's go here and just rewind these. Now, in this new scene, for example, I've got my particle interface. I even made a video on how to make this palette for anyone that hasn't done it before. Now, there are three types of particle-to-particle interaction: the blend, the flock, and the predator-prey. These three. And the predator-prey works with the two explicit particle groups, and one of them chases, the other one tries to fly away. And but you can control these, so you can create infection effects. There's some samples out there that are quite interesting. Now we have the flocking behavior, which generally uses all the particles. All these three, and the blend, where it sort of blends between the parameters of all particles. And what happens with these is that they all have these radii: pursue radius and flee radius and contact radius, and the flocking has cohesion radius and separation radius and so forth. And the blend also has the radius. With the radius, it's a bit tricky when you have a lot of particles, because every particle in your simulation, imagine you have 10. Oh, I'm not sharing my full screen. Thank you, Marco. Good. It's good to have production assistance. So let's quickly go predator, prey, flock, and bend. These are the three particle-to-particle modifiers. And they all have these radii here: pursue radius and separation and cohesion and all that. For each particle, the system needs to search in that radius to find any other particles, and depending on how close or far they are, to assign some sort of fall off and so forth. And if the radius is 5 centimeters, you will have a few particles. But if you start growing these radii to ridiculous amounts, 100, 150, and you have huge density, you are going to get simulation slowdowns. And that is one of those things that it can and will be improved, but even algorithmically, it's one of those things that does slow down these kind of calculations, like closest points and all that kind of stuff. So keep that under consideration. These slowdowns occur if you're using any of these particle-to-particle interactions, because it has to search all the scene and find any particles that happen to fall within those radiuses. Now, another thing I wanted to show was that because we added the new Toon shading in Redshift, I'm going to talk about it. This is a very simple particle simulation with just the turbulence. But it relates to particles. I have a whole chapter dedicated in how to use Redshift. I haven't covered this. And this is one of the things I need to add. In the new Toon material, there's a special setting down here that says opacity affects emission. Sorry. And what happens here is that it allows the particles to create some sort of additive rendering effect when you apply it. And makes it very interesting because you get those interesting sort of highlights. Look at these renders. Whereas without that, if I turn that off, you get your normal, these are emitting, and you need to have some sort of opacity and some sort of emission, and you get this blown out thing. Whereas with your opacity, you can control how much the particles are going to interact, and the rendering outcome is always amazing. So let's see if there are any questions. Let's see, and real world size materials, meaning real scale of the texture. No, this is a particle session. Please don't leave. And oh, who is that? Is that Marco watching on both channels? That's dedication, if not anything else. So let's very quickly set up our first particle simulation. All right. I'm going to bring everything up. These are all the tools that the particle simulation requires. There are no other tags or anything like that. And just create a basic Emit. That's it. Sean, welcome. Who else did I say hi to? And we may have surprise guests today. I hope they finish their meetings early and come and join us here. So the very important thing you need to remember when you create a basic emitter, it's very important, is go to the emissions tab where it says rate and add 3 zeros at least. If you don't do this, you are wimps, right? Just do that. So here is 100,000 particles. Now that's crazy. 1 million. And this is sort of the change of paradigm where you can have 1 million particles and not have to consider what the potential problems are going to be and all that. So here's my particle emitter. It emits 1 million particles per second. And if you want to see how many particles you have, you select the particle group and you go to points mode and look up here, over there, press play, and you're going to get a live count of particles, 1 million, 1.8, 2 million, chugging. Good. And don't forget, my computer is, I think, 5 years old. The first fundamental principle, which is very important, is that the emitter just gives the instruction for the particle generation. The particle data itself, the object that contains the particles, is the particle group. And the particle group is going to be the fundamental thing you're going to work with. So let's go here and shoot 1 million particles, because shooting 1 million particles is fun. You just shoot 1 million particles. There you go. And then you add, let's go and add from the simulate a turbulence force. And you make a little triangle. You do this here, and this here to make this little triangle. And you have this. And that's all you need to do to start making your particle simulations. How do you render them? Well, you open the Redshift render view, which should be in the Redshift folder, render view, and you click play. And that's how you render particles. Now, a few things. If you want to render using this or the picture viewer, you have to cache them, right? You will get them in the render view, but in order for the renderer to get all the data and render a final frame, you have to cache. And caching is exceptionally not difficult. You go here, you go to cache, and you cache the object or you cache the scene, and it caches it as an Alembic file. And if you're loading particles that you cached yourself, you use the particle group, not the Alembic input. Although if you bring the particles you have cached as a standard Alembic input, if you go here and you say open and open that file, it will come in as a thinking particles setup. So if you do have some sort of setup with thinking particles and you want to import these particles here, the only thing you need to remember is that in the TP settings over in the channels, you'll see a list with the parameters that these particles have. And if you're wondering what these parameters are, you press make this editable, go here, current state to object, sorry, right click current state to object, and you get this point object here, which has vertex weights, which are the float numbers, and vertex colors, which are the other ones. So this is essentially a point object with a bunch of parameters, and you can treat it as such. Now, this won't update. This is just a frozen one. So what this means is that if you want to clone on these particles for whatever reason, you just make a cloner. You add your object, whatever you want it to be. Make sure you set it to multi-instances if you're dealing with millions of particles, and set this to object and drag the particle group in here. Now we're going to get a bunch of cubes, right? And this is a million cubes moving around, right? So, you know, if we combine this with MoGraph, wow, I just made a masterpiece. You know, hanging out with you makes me feel like an artist, right? I'm saying it sincerely, just by fooling around. And yeah, that's pretty much how you create objects out of it. But again, because a lot of users are going to get carried away making millions of particles, make sure your clone is set to multi-instance. So please. So let's get rid of this. I don't see any complaints in the chat. Everything is live. The stream is going on. I'm always anxious about these things. So when it comes to rendering, there's one more little thing. Currently, Redshift considers these particles when you render them. Let's go to my Redshift render view. When you render these, it considers them what are optimized spheres. If you do want to change something about these or add a custom object, you have to go and add from the rendering tags and Redshift object, and you have to go to particles and set it to optimize spheres. So this is what internally happens when you don't have this, okay? But then you can use all these modes here. But optimized spheres is so optimized, it's so fast. You're going to see improvements. I made the mistake to use the sphere instances because I'm a Redshift noob, and I couldn't figure out why it was going so slow. Optimized spheres, boom, no problem whatsoever. And there's one little detail here. If you're using a custom object, let's get my favorite cube, 5 and 5, 5, and you want this to render as a custom object and drag it in here, right? We're going to see the cubes. That's a million cubes. If you want these to assume the colors of the particles, although in the case of the particle group itself, you put the texture on the particle group, but if you're using a third, an object as a custom object, you put the material here, although that material is going to contain particle data. So if you go here and you say user data, I have a video dedicated to all this, so I don't need to go too much into this, and you put this here. This material needs to be on the cube. I forgot to tell it what data to get. Color, user data, go here and say particles, particle, color. And this should bring the particles to be colorized green or whatever color you have. Talking about color. So let's temporarily close this. And let's say I want to colorize these particles as they live. Number one, I have many different modes in the properties here where I can choose my colors. I can have a random, I can have a noise. Noise is nice. It gives you a nice little gradient to choose from. Go grab your, I don't know, black, violet, orange, and then go and let's go to the noise. So you go down here, and what's my favorite noise? Luca. And go here, make it bigger as usual. And now it's going to create these particles. And there you go. You have your little particle color over here. And these colors should propagate on your, oh, there you go, on my cubes. So that's how simple it is. Let's see. Oh, yeah. Just like, well, fluid mesh. Everyone wants to make a fluid mesh. Oh, Basti is here. Basti, finish your meeting. Dismissed. So let's go back to the particles thing. Let me show you the volume thingy doodly. So you don't want to do this. You want to do volume thingy. Go here. You create a volume builder. Drag this in here. And there you have it. Now in here, because it's a particle group, you can set your own radius, or you can use the particle size. Currently, the particle size, which is defined on emission, it's the last parameter here. It's 1. Maybe I want to have a thing that's 10 with a variance of 8. So we're going to have a spread between 10 minus 8, so between 2 and 18, right? This is the spread, and this is the mid value of that spread. So let's do this, and we're going to get all sorts of particle sizes. Let's go here, and you can say use particle size, and you have your multiply. Oh no, they're just too big. So I need to go to this and say, no, I'm going to make it 5 and 4. You can see that those are going to be smaller, and you need to have adequate small voxel size. Now you can see all these nice little blobby thingies happening here. And of course you can measure, and of course you can play live, right? Is it a million or just 100,000 particles? Oh, it's 100,000. Sorry. I meant a million. I was lying to you all along. So this is the speed that it takes to emit, control, voxelize, and mesh a million particles. I don't want to hear any complaints, right? So let's see if we have any questions. Oh, yeah, Basti is, Henry is asking, do you have to change the original material to a specific material? You need render engine like Arnold. This is not a particle question, but you do. Yeah. If I understood the question. So let's see. Do we have any questions? Prefacing it with question allows me to read them better. All right, let's continue down the line here. Now, we have 3 types of emitters. One is the basic emitter. Sorry, 4 types of emitters. One is the mesh emitter, and this is one of the highlights of the new concepts of the system. Let's make an icosahedron because I like it. Here's my sphere. Good. And with the sphere selected, you just set mesh emitter, and that's it. Now it's going to emit from the mesh. Now let's go and emit. Well, these are these values. A million should be the actual minimum. So I don't want to emit from the whole sphere. I want to emit from some sort of pattern. So you will see that when you're in the service, it gives you this restriction. And there's a new concept here that allows you to know these are polygon and point selections, not vertex maps, just point and polygon selection. So go here, add from the other tags a polygon selection. Let's go here and add a random field with, of course, a Luca noise. And let's make this a bit bigger. Now, there's a nice little tricky madoodle here. If you go to the particle group, but not the draw, it's, the mesh emitter. And you go to the draw, and it has draw geometry. So it will give you some sort of indication when we go to the emission and we link this to the restriction. So now, upon the first frame, it even tells us with these little triangles where that emission is going to occur. In this case, maybe hidden line is, oh, look at that. Basti. So you can see in Grow shading that we get an indication where this noise is coming from. And let's add animation speed. So now it's going to emit from different parts of it. And of course, to make particles live less, to make it a bit more interesting, the lifetime is set to 0, which is infinite. I can always say, always twirl these arrows down. I want them to live for 25 frames with a spread of 15. And now we're going to get this interesting little pattern here happening. And this alone, I mean, looks fine. But these are the emission principles. Then we have the reproduce. I would suggest you go and check out. Adds some light in there. Mr. Pliss says, add some light. What do you mean? You mean to clone lights? I don't, if you can clarify the question. Well, we don't have fluid simulations, right? We have a particle simulation with 3 particle-to-particle interactions. The question was, what about fluid sims? And Basti is here. You can ask him that question. So the reproduce allows you to reproduce particles from other particles. You have to be very careful, though. The system works in a hierarchical manner. And this means that anything that lies within the root hierarchy or any hierarchy that's not a particle group will be executed in every frame. This is a concept I've covered in the tutorials, but let's go and see what this means. Go here, mission, and let's add a few zeros here. Now, let's go and add another emitter. Let's go and add a secondary emitter, put it here, and let's change its color. Let's go properties and say color. Let's make it, I don't know, ready. There we go. So we have these 2 particle groups. And again, let's add some zeros there. There we go, 2 particle streams. Now, what if I wanted to control one of them in a different manner? Well, this is where the hierarchy comes in. I'm going to name these 1 and 1 and 2 and 2, so we know which one emits in which group. Anything you put as a child of the group is what is going to be considered for that particular group. And the concept is extremely simple and transfers over the whole system. That's the great thing. It's consistent. So now that if the turbulence is here, doesn't matter where it is, if it's in the hierarchy, although order does matter in different ways, but because this is, you can put it in a null, you can put it in a null, over null, over null, over null, it doesn't matter. It will still execute for everything, right? Both of them are receiving the turbulence. But if I take this and put it as a child of one of the groups, rewind, then only that group is going to receive this. And this starts showing what the fundamental principle of controlling your particles is. You make them switch groups, you tell that other group what to do, you switch them back or do stuff like that. So this is how you're going to work not only with modifiers, but with conditions as well. And conditions is the control mechanism. We have 3 types of conditions. We have the simple conditions, and these are truth statements. For each particle, you make them childs of the groups. For each particle, you probe any of the parameters, for example, the age, which is the default, and you compare it to something, and you can stack them using the typical and, or, XOR, or inverse. I'm not going to get into that right now. The one thing you need to remember about age is that you cannot say when the age equals 30. That's not going to work. And the reason it's not going to work is that the particles are usually emitted in a subframe to avoid the typical banding issue that could occur with particles. Look at that. I turned off this continuous, which is what avoids the particles. But that means that the particle is not born exactly at the time that the frame started or ended. It's going to be born with a fraction of a frame of an age. To be able to catch the particles that are 30 years old, 30 years old, sorry, 30 frames old, you can do an inside range and say particles are between 30 and 31 frames. So it's a simple, this is something you need to learn, but this is what you need to do. So particles that are within a range of 30 to 31 frames, that's a 1 frame range, and it will catch any particle that is 30, 30.1, 30.2, 30.000, whatever. And this condition now, we keep the principle of children in this condition. Let's make this 60 to 61. Anything we put as a child of the condition now is conditionally going to be applied when this condition is met. So let's do something. Let's add a gravity. I think that's a good one. Going to add a gravity and increase the gravity so they fall relatively fast. So let's count frames here. We don't need, oh, well, let's leave group 2 there anyway. So let's see what happens at 60 something frames. Boom. There you go. And the way this works, look at this little slither of particles. This is an interesting one. I've got the condition selected. If I deselect it, that disappears. If I select it again, the condition, when we select it, it highlights those particles that satisfy the condition. It's a great mechanism to troubleshoot, to do your setups. And what is happening here? Why aren't these falling, they're just bending downwards. And I'll explain why. I can get rid of these now for now. Here's the proposition. The proposition is that any particles that are in group 1, check. We need to see if they're within the age range of 60 to 61 frames. When this condition is satisfied, then a gravity is going to be applied. But see my error here? This condition is satisfied only for a duration of 1 frame. So there's a microgravity applied to it once. It bends it down a bit because it's applying gravity and turning it off. If I want this to be continuous, I would say not inside range, but greater than. So when they're older than 60 frames continuously, that's when the gravity is going to apply continuously. So you just need to get, there you go, that's it. You just need to get a bit more familiar with these logical functions. I'm going to have a sip of coffee. And let me show my face so you know that it's me and not some sort of machine learning device. So what was I saying? Whenever I say something, I lose my train of thought. I'm too old for this. And I'm going to put myself, I'm going to remove myself. I don't care. So the principle of making modifiers and conditions and various other mechanisms children of the appropriate mechanism is what allows you to do all these things. So it's once you get a grasp of it, then you can do whatever you want to do. And as far as conditions, we have, of course, the field conditions to control things with fields. So let's leave gravity here. And it's a very simple one, but your performance will suffer if you're talking about millions of particles. I don't even know. Let's see. The same thing. This condition now. Oh, I didn't do field condition. There you go. So field condition, the field list, and the satisfaction of the list will occur. Let me bring this back to 0, 0, 0. I don't even know why. Oh, yeah, I moved it there earlier. I'm going to put my little sphere. It doesn't need to be there. It can be anywhere you want it. Over here. There you go. Any particle that falls inside this will get the nod. It will be true. But it doesn't, the fall off itself doesn't affect each particle differently. This is like selecting polygons. It's either a polygon selected, so the condition is true, or not selected. We don't have partially selected polygons. And you just control the tolerance. So basically, anything that passes the 50th percentile mark somewhere in here is going to get this condition satisfied, and it's going to drop, and then it exits. You'll see that it continues downwards. And let's make this a bit more interesting, right? So I'm going to go and create a friction. And basically, I'm going to use the friction in another field condition. Right, this friction, I'm going to go to the field condition and create a linear field. In the -y, I want it to point downwards. Make it smaller and drag this down here. So what I want to do is any particles that fall under the threshold of this, I want them to have friction. So let's pull this out. You can leave it there, but it doesn't matter. I want them to have a lot of friction. So these two things, I want them to work in conjunction, right? Well, separately, sorry. I want them to separately. If I want them to work in conjunction, you put it here and you use these ands and all that to say, when this happens and that happens, do something. Or when this happens or that happens. But in any case, now I just want them to work like this. Now, because we just have one group, we might as well put them out here on the root level. Doesn't make a difference. But it's good practice to start working with groups, just in case you add a new group at some point and you don't want them to affect everything and so forth. So let's see what this is going to do. So they move. Always increase your frame range. Particle's going to fall, and there you go. So this is what's happening here. The first condition checks which particles cross that 50th percentile, which you can see by highlighting it's right here in the middle, where the 50th percentile of your field is, because here we have a value of 1, here we have a value of 0. And then they start falling. And when they get within the range of this, you get your field condition applied. Now, of course, there are other ways to control this. You can use your friction with this, with the field in the field list directly, but this is particle agnostic, right? So it will do something very, very similar, as you can see, but it's not based on the condition. These are conditions. If it meets the condition, it says, yep, do it. If it doesn't, don't do it. Now, how would you go? Right, this is, we actually have a way of showing the comments selection, so persistent freeze. So let's show this. How would you go about making that selection? The sphere is producing persistent. Okay. So you want it to sort of grow. I think the freeze layer is what you are going to use. Let's see if I understood this properly. So first of all, let's turn off all the particles. And if you want to check, if you want to check the selection status of your not vertex mask, but polygon selections, or point selections, actually polygon selections on a procedural mesh, the best thing to do is just go and add a Cinema 4D standard material. It doesn't need to be a Redshift material. And go here, and you can make it red, and then confine that material. This will give you the proper selection, right? That is a residual thing from before. I don't even know what's there. Yeah. Let's turn it off over here. Draw geometry. Okay. So this will give you this. Now, let's see if the freeze is going to work. It should work. You put a freeze over here, and you add it to the previous one, and auto update. And this should, yep, there you go. So this is what should happen. If I make my noise go slower, why is it going too fast? I don't want it to go too fast. No auto update. There you go. Oh, I do want it to auto update. I don't want it to grow. Yeah, something add normal. No, I need to do add. It's going a bit too fast. I need to think about this. Yeah. Maybe it's because the random field is animating. Let's see. Oh, it still grows. Okay, I need to check this out. I need to check this out because I do not know why it's doing it. Let's see. But this would be the technique to make your noise grow using the freeze layer. That will be it. So let's see. What other questions? I mean, let's go here for clarification. I mean, if the particle is affected, by the spherical fall off. Okay. I need to read this a few times to understand. So you want it to continue. Yeah. Okay. I think I get it. I think I get it. So, and actually, that's an excellent question. If I understood properly. So let's go back to this, right? And I think the question is, when the particle enters, that it's going to fall, and the gravity only applies while it's in here. When it exits, the gravity doesn't apply anymore. And if it's not gravity, it could be something else. And the question is, how do you tell the particle to retain the gravity, although just use this as a trigger? I think that's what you mean. Use this as a trigger. And the way to do this actually is the following. You create a new particle group, and you can call it, let's say, triggered group. And you can override your draw. So I'm going to make them red when they enter that. Instead of putting the gravity here, what you do, you put the gravity in this one. Now, this one doesn't have any particles yet. And you use the switch group over here. So once the switch group has occurred, the particles are not here anymore. So they won't need to satisfy any condition. So the switch group, you need to set it with what group to apply to. So now they're going to go in, and they're going to turn red. There you go. So any of these particles that satisfy this condition now, just switch group. they don't get the gravity applied, but it happens that this new triggered group has gravity. So from this point onwards, the gravity is going to apply continuously because there's no other check. So if this was what you wanted, switching groups is the way you would go. And there are some tricks which is part of the new tutorials I'm making these days. And basically, you can combine these switch groups in ways where you can reset the particle age and then do a test for its age again, add randomization and all sorts of other things. Let me pull up some of I think I have some scenes here on the side. Rolling spheres running, I think. Where are they? Let me see if I can find any of these. Anyhow, I can't find them now. I didn't prepare nicely. So, what is the particle banding going on based in the sphere? I don't know about the banding. Let's see, banding. What's particle banding? Let me share my screen here. You may get, when you have extreme forces, some sort of minor banding, but if you do, this is something we need to look into with this. Yep, let's look into this. Okay, I can see it. We shall see. We'll be in touch about this and what ways potentially you can use. Let me make sure continuous is on. Yeah, it's good to get these comments and know what's going on. Now, let me all right. There's a nice question here. Let me find it. From S Motion. Let's go here. Hi. How can I make particles start from a point on a surface and spread out in the system? Sorry, showed it, but no, I didn't show it, although I just made a tutorial about it. Now, when it comes to mesh emission, let's get a platonic, let's get a mesh emitter, and automatically it applies it. The mesh emitter now is emitting in the particle group, and it's emitting from the platonic. So you want to emit from points. And this is a bit confusing, but that's why I'm making a tutorial about it. When you set it to points mode, at least the way it works currently, it emits one particle per point per frame, or one particle per point per second. And you will say this is annoying. And my answer is, yeah, but there's a very simple solution. Okay. And here's how you solve this problem. Let's go and instead of using the platonic as the emitter, what we are going to do, and you just have to do this once, make a little disk and put it on the +Z and clone it on your platonic and use vertices and make it smaller, as small as you want. Because you can't clone emitters, but you can clone geometry. Put this then under connect object. You have to put it under connect object. And now you use this as the emitter. Now, it took me literally 10 seconds. I don't want to hear any complaints about this. And here now you have your emission going on. Let's add a few frames. So let's go to the mesh emitter. Of course, let's go and emit in the emission. How many? Oh, yep, the mesh emitter. I'm going to emit from the surface. I'm going to emit a few more million particles. And you can go to the properties now. And you can say, if you go to the velocity underneath over here, it has not the variance, in the direction, it has a spread. So you can create a nice little cone. You can bias it towards the center or not. And then you can just take your little object here and rotate it. What am I not selecting? What's happening here? Why is it not rotating? Oh, sorry. It's in object mode. I have to rotate the object. Duh. There you go. Boop, 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 boop. There you go. You have a fancy emission. And you can make this very, 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 very small, and it will emit from literally a point. So although it sounds like a workaround, it's just a few seconds to set it up. No complaints. let's see. Chad Ashley, what up? What up? And Oliver, Master Trainer Oliver. Louisa, let me put my face back here. And let's see Oliver's question. Oh, no, actually, I'm going to. Oh, yeah, Oliver. There we go here. Could you use a random field in overlay mode to avoid the banding stepping with fields? I don't know. Why don't you make a tutorial about it? There's your answer. And let's go to the next one. I have Oliver on speed dial. I can call him and insult him anytime, so don't worry about that. How can I simulate particles from star, inspired black hole, and turn around? Oh, right. There are some tests, but we can emit from splines. So let's go here, create any spline. Let's make a star because a star was mentioned, and you just create a spline emitter, and this now emits from the spline. And you can use a tangential here to move them in the tangent, and you can go here and you can increase the number to ridiculous numbers, and then you can take this and you can rotate it. Anyway, there are ways to do things. Right. Oh, look at that. Makes funky shapes. Yeah, and I think we can also go to the properties and let's see, add emitter velocity. If you do this and you rotate it, they assume the speed of the emitter as well. So if this is emitter, I have to rotate the proper object. Look at that. As this is rotating, it adds that velocity. Oh, this is so funny and so fun. Don't tell Max on that. I'm having fun doing these. So I missed the part with the banding. Let's see the comment from Sebastian. Just so that you know, Sebastian is a senior software development manager, responsible for everything that's good about the system. None of the bad. There are no bad. So the part with banding, one reason for banding can be the condition masking strong force. It can be avoided by using a bit of chance in the condition. There you go. So let's see if that is something we can do here. If I find my file, let's see. Yeah, you have to rewind. If you switch projects, you have to rewind. Let's see if right. So if I go in the, let's go in the field condition, and it's a field condition, so we don't have chance. Maybe we can mask it with a bit of noise. Let's see if we can do that. Let's get a random noise here and multiply it, and take this noise, make it bigger. Add my favorite noise, which is Luca, animate it, and see if that's gonna reduce the banding. Basti, we need a solution. Okay, next. Oh, I had my screen obscured. Sorry about that. So basically what I did here, it didn't work, is I went to the field condition and I got a random field, multiply it, change the noise, and but we still have this on off. Maybe another condition that is softer that allows for a fall off would be a better idea. But anyway, this looks fancy as well. Look at that. You can use this in different ways. Okay, let's see what other questions we have. If it's a field condition, you can do what Oliver suggested, add a little bit of variation with a random field overlay. That's exactly what I did. How can droplets be made for a bottle or a can? Well, you just create random particles that are not moving. That's all you need to do. So let's make a bottle, right? This is a bottle, whether you like it or not. Let's use a mesh emitter and set the speed to 0. And let's shoot a certain number of particles and press play. Right now, if I take the cylinder and move it, you will see that they're not stuck. Right, they're over there. So what you can do in this particular case, I just dropped something. I hope it's not something expensive. You use a stick modifier. Now, in order for the stick modifier, which is one of the simulation modifiers, to work, you need an object with a simulation tag, a collider. Now the particles are going to stick based on these and collision because they're generated here this shouldn't have a problem. So if I take my cylinder now and move it around, they're stuck. So here are your droplets. And then you can add some other modifiers and make them sort of droop down and maybe even come together using a, why don't I do that? Let's try this. Okay, let's try this. We've created our little particles on the surface. Good. Now I want them to sort of go downwards. So I need to add a bit of gravity or another force. Maybe we can simulate that. I'm going to put this at 9. Or I can do a surface attract. That's another way to do it. We have stick on stick. So let's get them to stick a bit, not too much. And let's increase the gravity here and see what's going to happen. Are these going to move at all? Rewind. Let's make the gravity. Oop, and the stick. Okay. Stick. That's an interesting one. They do stop after a while. I thought the stickiness on collision would be, see, this is a good, I'm taking a note, droplets sticking. Now, I'm going to use another one. I'm not going to use the stick. I'm going to use the surface attract that has a follow and see if that is going to allow them to do some. Okay, we have that, increase the strength. Let's see. All right. And we need them to go slowly damp. So I'm going to set the strength to 20. Let's see, do that. And I'm going to set the damping to a high value. Okay, there you go. And you just control the gravity now. And this should give you something that does something. So Basti is working, right? We're having fun here, and Basti is actually doing stuff. So this would be the beginning of your setup. So let's get rid of the stick. You create static particles using a shot. You make the velocity 0. Then you add a surface attract, which attracts them to the surface. You play with the parameters so that they have a lot of damping. They sort of stick there. Now, if you want to change the particular behaviors for the floor and whatnot, you can add a field. You can add all sorts of things. And you can tell them when they reach a certain Y value to do something else and so forth. So, but this will be it. And let's try this. I'm going to go, I want to see if I can get some cohesion on these particles using the flock modifier. Now, the flock modifier, but I'm putting it first. So first it applies whatever flocking is going to happen. If I turn this off and just create the particles, you will see that immediately they're going to assume some velocity because they're trying to come together. And there's also a repulsive sort of force. I'm going to set this to 0.2 so they only come together. There you go. So they're creating these things. After this is done, I want them to be attracted by the surface. And after that, I want the gravity to occur. So this potentially, and go to the particle group and extend the radius a bit so we can see them a bit better, maybe 3. And maybe the flocking strength needs to become a bit bigger, or even the cohesion strength, and increase the radius. So rewind, press play, increase it, cohesion strength. Doesn't have so much application here. Whoa, what did I do? Yeah, I guess the surface attract may be a bit too powerful, and it's causing this, or the damping, 99. Oh, that's, I've put the flock at ridiculous amounts. That's why. And this is what happens when you experiment with things. So in general terms, you would use a combination of your forces to do things like this. And maybe in this particular case, a little turbulence before here. Yeah, the surface attract, that will be an interesting one because I'm not getting any effect of that. You'll see if I do this, the turbulence executes after the other one. So they will fly away. So this is a matter of putting things in the right order to get them to flow a bit better, to work a bit better. As you can see, now we're getting some sort of pattern and so forth. Okay, let's see. Circle packing options for condensation particles. Yeah, I guess, circle packing with their radius. Yeah, that would be nice. We don't yet. Maybe there's a way using the flocking with because you can generate particles and have them sort of avoid each other, but it doesn't take the radius into account. You can create a disk and create a mesh emitter again with your static particles in shot mode and 2, 3, 1, 2, 3. Have a million particles here just generated and 0. Let's hide the disk. There we go. Have these particles. Maybe a million is too much for this test. Not because of speed, but because we can't see. There you go. And now we can use the flock modifier. And the flock modifier without any cohesion, with a bit of separation. So you'll see these are going to try and run away, as you can see. The radius of each particle is not taken into account. The next thing you can do to just freeze them is to add a very strong friction, 200, and this will sort of push and pull and get them to sort of solidify their positions after a certain degree. If you're happy with this, actually interesting pattern. Yeah. And if you want it to evolve faster, you reduce this. And when they get to a point where they're all far enough from each other, which the goal is to be 5 centimeters, 2.5 centimeters, maybe 1 is the goal. And of course, you can animate those parameters as well. But in any case, this is how you would do something like that, the condensations and all that. Just make sure you have enough of this friction to sort of stop them in their tracks. That's an interesting effect. Okay. Yeah, you need that radius control. Let me see what other questions we have here. Let me put my mini face here so you can see I'm still here. Have I missed a question from a mesh emitter that can emit particles from any polygon object, also via polygon selection? I guess combination surface. I guess the attractor flocking might spread evenly. Yeah, that's what I was just showing. That was an old question. Let's see. I'm just going up the questions. Good. Usually I tag them. I didn't do that now. Doopy doopy doopy. Okay. We're good with the questions over there. So let's let's see what else we can do. Oh, we're over the hour, which means that my responsibility towards you has been met, but I don't think I'm ready to leave yet. So let me go and turn all these off. And let's go close this. Does anyone know how to get the no button without having to move my mouse? I don't know how to operate a PC. Let's go here. Do. I just don't like so many of these things here. And please go watch all 40 tutorials. Don't do anything else on the weekend. Just watch the tutorials. So let's see now. Let's just make something that I guess seems nice, seems interesting. And what I'm going to do is get a basic emitter. And I'm going to emit from a sphere. Let's see what the chat asks. Maybe that's more important. Are there any conditional triggers or ways to limit the effect of a field on a certain amount of Particles. Particle count is not something we can control, as far as I know. But no, particle count is not something. Conditions will be based on these properties: age, alignment, angular velocity, color, distance traversed, group, lifetime, position, radius, velocity, and so forth. Okay, let's do a fun setup. When you use a cube, it emits from these four sides. Okay, just like that. And one of the setups I did recently was to create some sort of angular grid where particles move in various angles. So what I'm going to do here is I'm going to use a time condition. The time condition, I'm going to call this initial. Now, the time condition allows you to pulse. So you say, I'm going to start at frame 30. I'm going to pulse for one frame, and then I'm going to get a gap of 30. And this, every 30 frames, it will pulse. It will give one truth statement. Okay. And what I'm going to show you now is the principle of divide and conquer, which it's the tutorial I'm going to be recording first thing tomorrow. And this one here, when this trigger happens, so let's start from the very beginning. Let's say we have an arrow. Let's take the null as an arrow. If the null is moving that way, if we wanted to change direction but not go backwards, it can go in four possible directions. It can go up, it can go down, it can go right, and it can go left. Once it goes right, I want the particle to point in that right direction and then start its journey again. It's going to be moving forward, and it can go up, down, right, or left. Right? That is the logic that we're going to have over here. So this time condition, when it executes, I want the particle, which by definition, particles, if you go to the handles here and increase this, you'll see they're emitted with a z-axes in the direction of travel. That's the default when you're emitting using the normal direction. And the velocity is going to be in that direction of the normal. Imagine this is a cube and it's traveling that way. This is how particles are, by definition, oriented. You can change those orientations by changing the alignment. You can see the alignment is the forwards vector, which is always the z. When Cinema 4D refers to the forwards vector, it's the plus z. The object that shows that conclusively is the camera. If you make a camera object, you will see that the plus z is facing forward, and there's nothing more important about facing forward than a camera itself. So if you forget which one it is, make a camera and look at the axis it's pointing at. So when we're talking about the forwards, the forwards vector of each particle, that's the plus z of the particle. That's it. And that's which way they're moving. So what I want to do with these particles is when this condition is met, I want them to turn, let's say turn right. Turn right should be, according to its alignment, the plus x, right? According to the alignment of the particle, that goes that way. The plus x is on the right. Good. So the particle turned right. Now, let's go and see what this is going to do at frame 30. Boop, 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 boop. So this is going right, and this is going right, and that's going right. So you can see now they're moving on their x-axis. Now, the problem here is that if I want these to execute the next set of turning rights or turning lefts, the problem is that they're pointing in that direction. So let's keep playing here and see what happens at frame 60. So frame 30, one turn, frame 60, and they're all going to end up going in the same direction because these are already going in their plus x. Only the new particles that are born. And if I set this to shot, you will see that we get the particles, they turn, and that's it. They're not going to turn again. In order for them to turn again, I need to recalibrate their direction, their orientation, so that they're facing frontwards. So you use a look modifier. There you go. So the look modifier tells the forward vector, the plus z, to point forwards. So after they turn, it will turn them around so they're pointing forward. So now these are going to go. Look at that. Good. Now I want to create 4 different conditions. Condition right. I want to have a condition left, which everything's going to be the same, but turn is going to be left, and it's going to be the -x. Then I'm going to have condition up, which is +y, up, up, and this is going to be +y, and down. We're getting there. Patience. Down, which is going to be -y. Okay. Now let's see what this does. This is going to guesses. Nothing happens. And the reason here is that all these are going to occur concurrently. That's one of the problems of the whole system. Found the reason for banding. Fields and CPU are therefore, all right, let me put this up. Okay. Therefore, we download all the particles of sampling the field for max performance. This is only done once per frame. Aha. And yeah, and my guess is that you're going to fix it so it's faster and works better. Thank you very much, Basti, for the commitment fixing the banding. So let's get back to this. Now we have 4 potential directions to go, and we want, so ignores the sub-steps. Yep. So we want about 1/4 of the particles to go in one direction, 1/4 of the particles to go in another direction, 1/4 to go in another direction, and 1/4 to go in another direction. Now, you may assume that we just select all these and we set this to 25%, but that's going to kind of work. Yeah, sort of work, but it won't work. And just want to show my conditions are all correct. Turn right and look. Just making sure. Yep. So the best way to do this, and this is what I'm going to wrap it up because my brain is getting fried, is the following. Instead of doing everything in here, it's better to do the following thing. Create 4 groups. And this will help you with how you can extend this setup. And call them right, left, up, and down. And what we're going to do is take the right, put them here, and the look, I don't even need to put it here because I want all the particles always to look in the same, in their traveling direction, right? So instead of telling each particle every single time, do it, you say, particles, just look in the direction you're traveling. And I want to turn right, I want to turn left, I want to turn up, and I want to turn down. And when these conditions are met, what we're going to do is we're going to switch groups. Switch group. And this is going to go switch group up. This is going to be switch group down. I'm not going to rename them because it takes too long for me to type. And we just need to make sure that the switch group goes to right. This switch group goes to left. This switch group goes to up. And this switch group goes to down. And basically, when they've done their turn, and the reason I'm going to explain when we go to the divide and conquer technique. The minute this condition is met, the way conditions, when you are probing the group using a child of a particle group, when you switch group, the minute this is satisfied, the particle is out of the loop. It's not in here anymore. If you do it with everything else, if you change their color, for example, the last of all the conditions, if you have 4 color changes, the last one is going to be the definitive one. Because the way the conditions work is a particle is tagged with whatever this new parameter is, in this particular case, the group. But the switch group, being very particular, when it's used in this context under a group, a particle group, will immediately switch. So once this condition has been met, and any particles have switched group, they don't exist for the second condition. So this means that now we need to do some very quick arithmetic to realize what we need to do here. And this is what we are going to do. Right? Set them back to 100%. The first condition wants approximately a quarter of the particles, right? These are the ones we're sort of targeting to have an equal division, a quarter of the particles, so 25%. When the 25% of particles have gone to the group, up, right, left, whatever, we are left with 3/4 of the particles. So now we want 1/3 of the particles. So we need 33.333%. At this stage, we are left with only 2/4, which is 50%. So we need half of these. And the last one is 100%, the remaining ones. Now, you may think that, oh, what if I have 5? Do I need to change numbers? No. The 25, 33, 50, and 100 are always there. If you want an extra one for a fifth direction, you just make it half of 25%. And if you want an extra one, you go here and you say half of that. And so it's very simple to do this. Is it half or something like that? But it's, you always end up having 100, 50, 33, 25, and then it's 1/4. Sorry, I was wrong. It was not half. This is 1 out of 4. The other one is going to be 1 out of 5. So you go here and you say 100 divided by 5. So that would be 20%, and so forth. So what this should do now is a quarter of particles and a quarter of the particles and a quarter. So a quarter of the particles, and then a third of the remaining, and then half of the remaining, and then the rest are going to go into these groups and do these little turns. Once they've done the turn, though, we want them to enter the loop again, correct? Now, in order to do that, we just need a switch group. Where's my switch group? It's down here, just to return to the proper particle group, because we're creating a loop. And this is just, sorry, this is just a repetition of the same thing. So what should happen now is that actually it's not going to work, because we need to do one more thing. It's going to do something. Good, it's switching. The only thing you need to do now is change the seed, because now it treats all the particles with the same seed. Select all your time conditions and just go to seed and type num. This is something you can add to names of objects and all that. So this is going to be seed 0, 1, 2, as long as they're different, it doesn't matter. And now you get this interesting grid moving thing just by doing one operation, one group, and then just multiplying this by all the 4 directions you want to go. And let me do the final thing. Go to your initial group and go to MoGraph and add a tracer. And here you have your little group. I'm going to change these to be dots and make these 2. And there you have your little griddy thing. And if you want to have 6 directions, so they go diagonally up and diagonally down and all that, that's also something you can set up with the appropriate number of things. I'm going to have a dedicated tutorial on this to show all the intricacies. And yeah, let me check to see if there are any questions, because we're approaching the hour and a half. Let's see. What does Quest, any chance you know about changing material color using keyframes? What do you mean? Is it about the particles or something else? If it's not about particles, next week is our regular Ask the Trainer, and you can ask the question. Be a bit more specific if you may. Thank you. Let's see now. So very good question, Tim42. So are the new particles already able to interact with the rope system? I couldn't get them to collide without sweep. The answer is no. We can only collide with actual simulation objects, not the rope. And yeah, this is using the collide object. So that will be colliding with cloth and colliding with colliders, and always with the under the new simulation system. That will be it. Okay. Vitus got his coffee. Great. You didn't miss anything, no. Okay, let's see if we have any other questions here. But please go. What I'd like you to do. So we are going to focus and put my beautiful face up here. Shall I have my screen as well? Yeah. So go watch the tutorials, right? I know they're a lot, but they're good, right? When I say good, it was a tight schedule, but go watch them so you can get all the technical information. That's stage one. By next week, we're going to have a few more, maybe 3, 4, 5, 6 tutorials more about how to build specific things. Then start putting things together. Start with a plan. I want the particles to do this and do that, and how to imagine things. You can always add random forces and just render them and tell people you spent days at making this. But start making setups. And as you're trying to develop these setups with a certain logic in mind, if you hit any roadblocks, take a note and come on the show or post it. I'm gonna in the closing. I'm gonna show that little QR code again, and start asking the specific questions. You can always hit me up on Twitter. I think here somewhere around here I have my Twitter handle. Let me bring it up. Doobie. Oh, both of them. Right. You can tag me or Jonas. Although Jonas, I think he's going to be at NAB next week. So we have that. Don't forget about that. NAB, very exciting. A lot of amazing artists there. And hit me up, DM me on Twixer, and be specific with your questions. It's very important. And if you can supply a very limited scene, if you save your scene at frame 0 with a particle setup without any other objects and all that, the scenes are extremely small. If you have some particles and save the scene, it actually saves that empty object, and it makes the file massive. So be aware of that. And let me get you that question thing. I think it's here. Just make sure that we have that. There you go. So I'm going to put it in front of everything. Peek from the side. Do that to ask your questions. Good. Let's get rid of that and check and see if there are any more questions here. Comments. Okay, let's see. So not the rope system. You can generate from a spline. We have a spline emitter, but no other spline interactions. The sweeping and all that, that's the way to go. And, because it's quite performant, I know it has that additional layer and all that, but that's the way to go. I noticed the keyframe icon next to color in the material editor. There are always keyframe icons. I don't know. Ask on Twitter. Kevin Rupp. Kevin. Me and Kevin are like this. Metalness. Ha! Good. So by asking your question was answered for you. That is the kind of magic we offer here in the training team. That going through the process of asking a question and the universe reveals an answer for you. That's very deeply philosophical. Okay. I think we are pretty good for today. About an hour and a half. I had a lot of fun. I've been spending a lot of time with the amazing team. And wherever you are, just generally look towards Germany. Right? Orient yourselves towards Germany, around Frankfurt. And next time you're having a beverage of your choice or some food, raise your glass to Basti and the amazing team of developers that put this thing together. And of course, when you find problems, complain. Right? Don't hold back. Be polite. Be critical. Be polite. And we need you. We need your feedback to make all the tools better. Don't be passive observers. We have a community here. We trust our users. Some things are out of scope sometimes, but the team is very excited to continue developing. So especially if you find bugs, if things are not working as advertised and all that, please report them. Don't be shy. They do help. It doesn't matter if it's been reported before. Just report. And if you're asking questions, which I try to get back at anyone. At least I put an effort in doing something. If I can't find a solution, I do reply. DM me on Twitter or send your question to Master Trainer. And that way we can address your individual needs or generally create content. And don't forget, when you ask questions, it allows me and the rest of the training team to create content. The last quick tip was actually a question from one of our users on Twitter. So there you go. No, Rip Insidium. I mean, let's let's take it easy. It's fantastic, but I mean, Insidium is a great company, and they make great products which have a wider scope. What's going to happen in the future? That's a different story. But anyhow, enjoy it. We don't have anything else. I'm going to do some reverse housekeeping. See, we have a technical term for that. Let me see where's my. I always lose my pages. Don't know if anyone wants to see this, but anyway, I'm going to show it anyway. So let's go back here. Max on events. Great place to go and get information about all the events. Let's bring up the QR code to ask your questions. I mean, how fancy is that? Like QR codes, and look at that. Take a snapshot, ask your question. Yeah, raise your glasses towards Frankfurt, please. Don't forget to do that. I'm not a very spiritual person, but I do believe in these big expressions of gratitude, and don't forget to do that. Let's continue with the housekeeping. Go to this page here where it has all the links. So Cineversity and certifications and training teams and Max on events, and ask your questions or say hello. Max on Training Team YouTube channel. If you missed part of this, go to the Max on Training Team YouTube channel and check out all the recorded videos with detailed timestamps provided by the magnificent Dr. Sassy. Hello, Doctor, wherever you are. And Max on YouTube channel. Fantastic content. Go check out the amazing animation made by Something's Awry. Beautiful stuff. Amazing group of talented people. Max on ZBrush YouTube channel. Go learn ZBrush. It's like the best sculpting software ever made. Go here and use the code. I'm looking at my other monitor. Where's everything? There you go. ZBrush print prep. Excellent. Let's put this down, and of course go to the new Cineversity, and these are the two series I did, and there's a new series from Chad Perkins, very good friend. Hi, Chad. About Red Giant Geo and many other things. I think pretty much done. The old Cineversity. And just like that, where's my face? Just like that, I bid you farewell. Thank you very much for participating. Let's stay in touch, and see you next week, I think. Ask the Trainer, and NAB is starting. Very exciting stuff. Bye-bye, everyone. I need to click the buttons now. Imagine that the video stream has finished now, and the producer is pressing some buttons. So I need to go here and do something, right? And let's see. I'm giving you a full interactive thing of behind the scenes, right? There you go. And end screen. There you go. I think this is the end screen. Bye-bye.